So sit down, please, everybody. We're going to start right now. So let's assume, just for a moment, that all of you here are ASP.NET developers. You've invested a lot of work implementing security mechanisms in your application. You've done pretty much anything that OWASP suggests that you do, and you even have a WAF, a web application firewall, that is properly configured to protect your application. Still, and despite all those security features, the attacks that I'm about to present in this session are going to work. And they can have some major impact too. They can enable attackers to change, literally change the database that the application is using. Change the database, replace it. They can enable attackers to activate administrative features all over the application. They can enable attackers to change the structure of every server-side page that it doesn't like. The structure in the server side, not the client side. And the best thing about it, it can be identified, the potential, completely passively. You don't have to attack. You can detect the potential by analyzing content that the server presents without doing anything special. And there is a tool set to execute and exploit each and every one of the attack vectors I'm going to describe in this session. You don't have to do anything manually. So with that opening out of the way, let's start with a short introduction. Hello, everybody. My name is Shay. I'm a security researcher and analyst, and also the CTO of a group called Hactics, which is an advanced security center of Ernst & Young. Hactics used to be a privately held boutique company, but it was bought by Ernst & Young in 2011, and since then joined the worldwide group of Ernst & Young security centers. I'm here to present a couple of new attack vectors against applications such as ASP.NET and Mono, but also here to present a project used to exploit them, which is currently nicknamed Vehicle, an acronym that stands for View State Hidden Control Enumerator. It's an OWASP ZAP extension, a project designed specifically to assist penetration testers in assessing the security of complex modern web application frameworks, such as ASP.NET and Mono. Now, instead of delving straight into the mechanics of the different attacks that I'm going to demonstrate in this session, I want to give you a glimpse, just a taste of what you'll be able to do at the end of this session using these attacks. Okay? So, in my demo application, I'm going to log in using two different users with different privileges. On the left side, I'm logging in with a simple user, a low-privileged user. And on the right side, I'm logging in with an admin user, high-privileged user. I'm going to access the same page in the application, page 2. And you'll notice that on the right side of the screen, the admin user has an extra button, the red button. Okay? That's the administrative operation that only he is permitted to execute. Now, in ASP.NET, there's simply a property called visible, which is turned to false when the developer doesn't want a specific user to view something. If I'll search for the name of that extra button, I'll see that the button's name is button 2. Okay? And if I'll search the same button in the second page, in the low-privileged user representation of the page, I won't find it, since it isn't even rendered to the client side. It doesn't exist. However, using the attack vectors I'm going to teach you, which are implemented in the vehicle extension, simply crawling to that page through the ZAP proxy and to a ZAP proxy instance with vehicle installed, you'll immediately be able to identify that that page that you're currently viewing contains invisible controls. Invisible controls that can be exploited and abused. And simply by right-clicking on that page, you'll be able to do a couple of things. In a matter of seconds, enumerate the name of the invisible controls using techniques we'll learn later on, identify the name, reconstruct the entire dotNet mechanism fields, view state, event validation, and so on, and execute the server-side event that you're not supposed to see or execute. So in this case, executing the event from ZAP showed us that the response of the server is initializing password for all users, which is the exact same response we would have gotten if the administrator would have executed the same event. Okay? Bypassing a number of security mechanisms along the way. So that's one thing we can do. But let's show something even more interesting than that. Let's take another example, another page. In the same application, there's a page here that uses an SQL data source, dotNet control, that accesses a table associated to a control. Okay? Now, this data source is currently nicknamed SQL data source 1. I'm presenting the data source name from the server. And the key field is account name. But by using the techniques I'm going to teach you, I'm going to demonstrate it in detail later on. I just have prepared in advance a JavaScript function with what I'm going to send later. Just by doing a couple of manipulations that you'll be able to do with the vehicle extension, you can actually change the data source that the application is using to a different data source. Cause the server to work in front of a different table and even if a different database with different key fields without using any SQL injection techniques or any SQL at all. Okay? Just using simple manipulations we're going to learn. So I hope this introduction got you at least intrigued for what I'm going to present. And let's discuss shortly and talk about the different attacks that I'm going to cover in this presentation. We're going to learn techniques to identify whether or not a dotNet or mono page contain invisible, dormant, or hidden controls that we're not supposed to see. We're going to learn a couple of techniques to do that. We're going to learn how to enumerate the type of the control, whether or not it's a button, a text box, an SQL data source, and how to enumerate the name and properties of the controls that we can't see. We're going to learn how to inject or override control properties that we're not supposed to alter or change. And we're going to learn how to affect them. We're going to learn how to use Google and similar caching repositories to bypass literally each and every single dotNet security mechanism, okay? Just by using Google or similar caching repositories. And we're going to learn how to execute those dormant and invisible server controls using a variety of tactics, okay? But before we're going to learn all that, let's discuss the mechanics of ASP.NET and Mono first, just to have solid basis to understand how this attack works. So these days, modern web application frameworks have a lot going for them in terms of security. There's numerous security mechanisms built into this platform designed to assist the developer in protecting his applications. There's the event validation and view state mechanisms and the max semi-signature that help developers limit the user to specific inputs, preventing him from changing inputs the developer doesn't want him to change, and preventing him from executing controls he's not supposed to execute. There's a built-in security filter designed to prevent numerous payloads of XSS attacks. There's a built-in regular expression in almost every .NET control out there that is helping the developer implement input validation with ease. So there's so much going for them as far as security is concerned. And the only edge that an attacker has when assessing the security of a .NET application is the increased attack surface. While a normal web application has a number of independent entry points, such as web pages, web service methods, global modules such as filters and handlers, .NET and Mono application, modern web applications that make use of server-side web controls have an additional independent entry point. And that's the event of a server-side web control. It's just like an independent page. You can access it separately and test it, okay? Just like a web service method. And what is a server web control? So a server web control is actually a component dragged and dropped into the design view of an ASP.NET or Mono page, which has both a client-side representation and a server-side representation. In most cases, it's implemented in the client side as some sort of GUI, a text box, or a button, or whatever, but the server-side code is executed instead of the client-side code. When you click or interact with that client-side component, it causes the server to execute a completely different section of code that isn't accessed when the page is accessed, okay? It's implemented as an event, and it's executed from the client side using either postback or callback methods, which are generally methods that send a couple of interesting parameters to the server: the event argument, the event target, and the view state. Now, the event target and event argument are pretty simple. They tell the server which control to execute and which arguments to deliver to that control. But the view state field is a bit different. The view state field is a base 64 serialized collection of properties that represents the current state of the page controls. So if we have a page that has a couple of controls in it, and the developer messed around with them and changed properties and so on, all the properties that will altered or change or whatever using programmatic means will appear in the view state. So it will represent the current state of the page for that user. Now, this view state is protected using something called a MAC, which is message authentication code, very similar to a digital signature, aimed to prevent users from changing those properties and thus affecting the server-side page state. And in addition to that security mechanism, there's another security mechanism called event validation, which has one sole purpose: to prevent users from changing or affecting server controls in ways that they are not supposed to. And it's also implemented as a hidden field, and it's also a base 64 serialized object. However, it doesn't contain properties. It contains the hash codes generated for the view state, and each and every, and that's key, each and every visible control, each and every control that the user can see will have its hash code included in the event validation, which also has a MAC protection, okay? Generated from the machine key of the server. And here lies the first punchline of this presentation, because that structure, the protection structure of dotNet actually discloses whether or not invisible controls exist in the page. If the developer caused any control to become disabled, invisible, using programmatic means, meaning code, if it changed the visible or disabled properties, the view state will represent that. You will see a visible equals false or enabled equals false or similar properties in the view state. If you'll analyze it, you'll be able to tell whether or not that page contains controls that didn't exist. Furthermore, you can go to cache repositories such as Google, Wayback Machine, and compare the previous snapshots of the event validation and view state fields to see if there's something you're missing. So you'll be able to tell in a number of ways whether or not that page contains or contained invisible controls. So assuming that I've identified which controls are composing the page, what can we do then? Okay? First of all, these controls populate the view state along the way. The view state starts pretty clean, and the more the developer messes around with the controls and changes properties, the more it gets populated to represent the current state of the page. However, there's two cases in which you can abuse that mechanism to change the properties for that page in the server side. The first one is obvious: when the MAC is disabled. MAC, although it's activated by default, it can be disabled by developers. And although that's pretty rare these days, it still happens from time to time. And the other option is to take an old view state, a previous snapshot of a view state from Wayback Machine or similar repositories, and reuse it. If it has the same MAC, which was generated using the same key, it will work, as long as it has the right structure and as long as it is for the same page. So let's do a couple of examples here, okay? Let's try a couple of examples here. So we parsed a couple of classes in dotNet, pretty much actually, and we've identified numerous properties which are loaded back to the controls from the view state. There's plenty of interesting properties in there, such as visibility properties, or data source ID, which tells the server control which data source, which database in most cases to use, the access key, the key fields, and so on. There's plenty of interesting properties. And if there's no MAC, instead of just writing in a pen test report, there's no MAC, now we'll be able to do something much more interesting. So let's take a demo page here. If I have an application that has a control that is invisible, the first thing I can do is simply to add the control, or at least add a visible equals true property by accessing a tool such as vehicle and editing the view state of the page, I'll be able to simply add a button or control or other type of control and make sure they become visible. So in this scenario, you'll see that an extra button was added after I changed the view state, a button called button 2 that can restart the server, okay? Just so it will become visual, I stored the view state generated in advance in a JavaScript method, and that's what happens when we change the property of the control in the view state. It becomes visible, and it now can be activated. It even becomes included in the event validation mechanisms. So even if there is an event validation active on that page, we can now execute that controls. It's included inside. Another good example, we showed it before, but I want to show it again, is the SQL data source example. So SQL data source, as we mentioned earlier, it's just a dotNet control, which is associated to a table with a key field. However, if those properties will be injected into the view state, then the server will reload them, actually changing the data source and key field in the server side. So if we'll use vehicle on that page, we'll be able to actually edit the view state and add the data source control, or again, similar types of controls. I think I got the wrong page here. Yep. So you can identify whether or not it's an SQL data source object according to the sparse array property here, and just injecting the relevant properties into that location will enable you to alter which name or which SQL data source it will use. So I'm going to use the default .NET name, SQL data source and the number, in my case 2 instead of 1, and I'm going to apply it, okay? And by posting back the event with the altered view state, I'll actually be able to view different content, access new tables, and even new databases, depending on the data source configuration that I accessed. So the values that I'm seeing right now are different than the values that originally existed and were presented by the page. Again, one way to do it is to do it when the view state mark is turned off. But like I mentioned earlier, that's pretty rare. Another way to do it is to use repositories such as Wayback Machine or Google Cache, just to gain previous versions or snapshots of that view state. But again, there's no point doing it manually when you have an automated tool for it. So Vehicle integrates with another project called Deja Vu. It's another Zap extension. Let's hope the internet is working properly, and if it is, I'm going to show you what it brings back for a real website online. Again, we're not going to hack into this website since this is illegal. We're just going to do everything passively. It's a website called Bankrate and just a page called Checking. And just by accessing the relevant page, let's hope we find it. Just by accessing the relevant page, we'll be able to use the Deja Vu extension to compare the view state and event validation fields from the content found inside repositories such as Wayback. It will automatically tell us whether or not there's a view state which is different, event validation which is different, and whether or not it contains controls that we can reuse to attempt and execute or override server properties. Okay? So whether or not there's MAC, we still have something that we can do that may work against a given application, as long as there's caching repositories for it. We can also get cache repositories or cached content from the browser of another user. Even using a station that an administrative user used will enable us to steal, to gain access to the view state and event validation fields that he can see. So we'll be able to reuse them for our purposes. Again, view states isn't necessarily session-specific. In most cases, it's user-specific, and we can reuse it. So it's one thing to alter the properties of these controls, but it's another thing to execute them. We can do a number of things that can enable us to execute the server-side code associated to these controls, which is even more powerful than just altering their properties. But before we're going to do that, let's define what are dormant or invisible web server controls. There's a couple of them. There's different types of them. So the first type of dormant server control is a commented control. And that's HTML commented. Since .NET ignores HTML content, it's HTML, it's not ASP.NET code or C# code, the control is rendered normally to the client side. However, it's not presented to the client side, at least it's not visible to the eye because it's in a comment, okay? So that's the first type of dormant control. The second type is disabled control, which is a server-side control that had the enabled property set to false, okay? And there's a couple of effects to that. First, the control is grayed out. You can't click it since the disabled property was turned on in the client side. But in addition to that, the control is not associated to a JavaScript post-back call. There's no association. So even if this property will be deleted or altered, clicking it won't do anything. There's no JavaScript association to it, okay? And the third type, that's the real deal. Invisible controls aren't even rendered to the client side. The hash code of the control doesn't even exist in the event validation field. And there's no client-side representation as long as you turn the visible property off or to false in the server side. So there's a number of different controls which are considered dormant, and there's a number of different techniques to execute them. And we'll start by doing it manually and then automatically using the vehicle extension. First, the simplest form, commented control. Like I mentioned earlier, .NET completely ignores HTML comments. It's not relevant. And just on commenting, any control will cause or will allow us to execute it. So I'm going to use burp in this session, so you won't be able to say I'm completely sold out on Zap. So I'm going to intercept a request and simply uncomment the commented control in the response. So it will become visible. It's supposed to be a yellow control for those of you looking for it in the GUI. And simply by uncommenting it, we'll be able to execute it. And it will work despite the fact that both the event validation and the view state mark are turned on in this page. All of the security features of .NET are active, but it still works, since, again, .NET ignores HTML comments. However, .NET ignores a couple of other interesting things, such as disabled controls. Like I mentioned earlier, disabled controls are rendered to the client side, but not completely. There's a disabled property which is turned on, and in addition to that, there isn't any post-back association. There's no client-side event that is associated to a server-side event. But again, we can simply enable it and forge the callback call with the right properties and the right values. Okay? Let's see that in action. We'll use burp again. Have a disabled control in this page and a disabled text box. I'm going to enable both of them and forge the do post back call. Okay? So again, I'll intercept the response. I'll delete the disabled properties from both the button and the text box. And I'll also forge a do post back calls with the right values. A do post back call generally includes event target and event argument. And the event target is simply the name of the control. So I'm going to send the name of the control here, which is button 3 instead of button 1. And just doing that from the client side, and despite the fact that all of .NET security mechanisms are active, will enable me to execute the server-side code associated to that control. All the security is active, and I'm still able to do it. And that's because disabled properties or disabled controls aren't considered a security feature in .NET. It's not related to security. But developers, or many developers, don't know that, and they still rely on them. We've actually, after talking about this presentation, about some of these attacks, we found that one of our customers was attacked using the same sequence by an attacker that changed or accessed disabled control and forged the same thing I just showed you, okay? And it was a credit card company. So we can do, or we can actually execute both of these attacks automatically using the vehicle extension. We don't have to work hard and forge it and uncomment stuff. You can simply right-click on any page that contains those properties. I'll forward the communication to Zap once more so we'll be able to see it. Just by right-clicking on this page and selecting the vehicle extension, you'll immediately see that the page contains both commented and disabled controls. And just by clicking on them, the vehicle extension will do anything for all the rest for you. And the event will be executed in the server side. Okay? Now, those attack vectors were pretty simple. But the real challenge is only relevant when we get to the invisible control section. And that's because the security mechanisms of dotNet are really designed to protect only this type of properties. Because when you cause a control to become invisible, when you set the visible property to off, dotNet actually removes the hash code of the control from the event validation field. So the server, when you try to execute a control you can't see, will be able to tell if you can see it and execute it or not. So there's a couple of ways that we can bypass this security mechanism. When there's no MAC, when the event validation is turned off, or when we have a cache repository that contains a previous event validation. And in very rare cases, or not so rare depending on the application, when the developer made a simple programmatic error. Okay? So let's go over these mechanisms one by one. As I mentioned earlier, when the event validation is off, the developer simply turns a simple flag to a false state. And developers actually do that a lot, because the event validation, although it's pretty useful, can make a couple of problems for developers, especially if they want the client-side controls to be interactive. So if the developer wants the dotNet client-side control to be able to accept values, new values from the user, he has to turn off the event validation field. Otherwise, it won't work. So there's many cases in which developers actually turn that off. And if the event validation is turned off, it means that the server has no way of knowing whether or not I'm accessing controls I'm not supposed to. Okay? So even if the MAC is on and there's security features and there's privilege validation and whatever, if the event validation feature is turned off, I can do what I'm going to do right now. So if I have a page, like page 3 in our sample application that has the event validation turned off simply by intercepting the request and changing the name of the button or the control in the event target to a control that I can't see, in this case, button 2, I'll be able to execute the event. It's as simple as that. I just fuzz or send a different name in the event target field. It's that simple. Terrible, but you can see the response yourself. Okay, I'm accessing a control that clears the database that I'm not supposed to see. However, finding the name might be difficult, which is exactly where the vehicle extension comes in. The vehicle extension can enumerate dotNet control names based on a dictionary, on default naming conventions of ASP.NET and custom ones, of course, and it can do it either using error-based methods, which we'll talk about later on, or using blind methods. Okay, and I'm going to show you the blind detection formula later on. So just by clicking that page, knowing that it contains invisible controls and activating the blind enumeration features, we'll be able to identify the name of the invisible control and, of course, execute it in the server side. Again, despite the fact that there's a max on the relevant fields. We don't have to guess anything. We don't have to do anything special. Right-click and a couple of other clicks, and we're in. We're executing server controls we're not supposed to see and we can't, or we're not supposed to have access to. Now, that's the first case. It's very simple because all I had to do was to change one parameter. I can do it, again, using tools such as vehicle or even manually if I guess the name. But it gets a bit more complicated when it's the other way around, when the MAC is off, but the event validation is on. When the MAC is off, I can mess around with all the fields. I can mess around with the event validation and the voice set and change them, and nobody will know. However, the structure has to be valid, and the hash code of the control I'm trying to execute needs to be inside the event validation field. Otherwise, it won't work. So assuming none of you is willing to do a lot of math and compute the hash code of each and every control is trying to execute manually, you can simply use skip, or in its current name, vehicle. Okay? So the vehicle extension can use a couple of very interesting .NET behaviors. A, it can reconstruct the event validation field for you and compute everything that needs to be computed. Okay? And in addition to that, I'm just going to use ZAP in this example. In addition to that, it is also able to use a very, very interesting behavior of ASP.NET that causes the server to present exceptions only for controls that we're not supposed to access. Try and figure that out. The server will present exceptions only for controls that exist, but we're not supposed to access. And let's see that in action. I'm going to follow the communication again for using burp, and I'm going to access a control that doesn't exist, such as button 9998, whatever. Okay, that's a control that doesn't exist. And instead of throwing an exception, nothing happens. Nothing whatsoever. It's just like accessing the page without any parameters. However, if I try and access controls that exist, but I can't see, that don't have a hash code in the event validation field, something very interesting is going to happen. Then and only then will I get the following exception. Invalid postback and callback argument, blah, 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 which is exactly the behavior that I need to enumerate the names of controls that are valid and I can't access with like 10 times the speed of the blind enumeration. Okay, so let's see that in action. Let's follow the communication again to ZAP and do that using the vehicle extension. I'll access page 2. It will immediately enable the button that enables me to do an error-based enumeration. It was disabled before, but because vehicle identifies that the event validation is on, so you can use that error-based method, I'll be able to enumerate it very quickly. The vehicle extension will reconstruct the event validation field with the hash code of the control name I'm trying to execute, and again, I'll be able to execute the control. Okay? And do whatever it is it's doing in the server side. So let's remember what we've done so far. We were able to identify whether a page contains dormant or invisible controls. We were able to alter or mess around with these properties if we found an earlier version or if the MAC was disabled. We've been able to identify whether or not we can execute server-side controls if either the MAC was disabled or the event validation is disabled. But that's not the end of the story. As I mentioned earlier, we can use the deja vu extension, which is integrated into the vehicle extension, to scavenge, to obtain previous snapshots of view state and event validation fields from Wayback Machine or similar repositories, and see whether or not we should reuse them automatically from the from whatever we're using or trying to do. Okay? But in addition to that, we can exploit additional flaws in .NET to execute those server-side events, even if all the security mechanisms are turned on, and even if Wayback Machine doesn't have anything that we can use. And there's a couple of ways to do that. Or actually, one main way. Okay? So the main way to do that is if the server is relying on callbacks instead of postbacks. So postbacks in .NET are generally form submissions. dotNet submits a form and sends the event target and the event argument alongside with the rest of the fields. However, a callback is usually used with Ajax in ASP.NET and Mono. And it sends similar parameters, such as callback ID, which is like the event target, and callback param, which is like the event argument. However, when you're using callbacks in ASP.NET, you have to perform the validation using code. You have to write validation code in the server side in order for it to actually validate anything. And although .NET, in most versions, adds that code by default to the event created, okay, or in the samples, the various samples of callbacks, the developers may uncomment that validation line for whatever reason, testing or some problems in QA or some problems in development. And if that callback validation code is commented, even if the mark is enabled, even if the validation properties are enabled, even if all of the protection mechanisms are active, we'll still be able to execute the control regardless of any protection mechanisms that exist. Apart, of course, from scavenging values that can help us from a Wayback Machine or similar cache repositories. Okay? So, as I mentioned in the beginning, no security constraints which are currently recommended by various security organizations are able to prevent most of these attack vectors. Nothing can prevent attackers from executing an event when they have scavenged a signed view state and a signed event validation field which contains something they need from way back. Nothing can help the developer if he uncommented the relevant line in a callback. And if he uncommented or changed one of the protection properties to false, that's even worse. Nothing can protect the developer if he relies on disabled properties or on commented properties of controls, and so on and so on. So we need to integrate a couple of new solutions to handle that problem. Let's go over those various solutions and guidelines so you'll be able to implement that in your recommendations to your customers. So first, there's no reason whatsoever to rely on disabled controls. .NET claims that Microsoft isn't the one to blame. It's not supposed to be used as a security feature, at least not in ASP.NET. That's just reality. You want a security feature? Use the visible property, not the enabled property, okay? Second, don't rely on HTML comments. They should have been extinct a long time ago, but they're still here, so don't use them. If you have a dormant control or a control that's not supposed to be there, which is a remnant of a test feature or some feature which is not relevant to the live system, again, remove it. Don't keep it. Don't rely on visibility features. Just remove it. And in addition to that, probably the most powerful thing we can do is to implement validation code for privileges in the events themselves, instead of just in the upper section of the page. So if we usually have a validation code for privileges, for the privilege level of the user, in the upper section on the page, in ASP.NET, we must implement the validation code for privileges in each entry point, and thus in the code of each and every event of each and every control. That's the only way to defend .NET applications properly from these attacks. In addition to that, it's always a good idea to activate the validation and MAC features at any cost, make them true, since they do provide some measure of protection. And of course, since we realize that caching features are relatively dangerous in .NET because of the usage that attackers can do for old and obsolete view state and event validation fields, it's recommended to disable caching in .NET, at least in any page that contains controls. And there's a code sample for that here. And it's recommended to make sure that crawling engines won't store previous snapshots of your application. And you can do that using the robots files. Okay? Finally, it's probably a very good idea from time to time to change the machine key of the ASP.NET application, since by changing the machine key, it will cause all the previous view state and event validation to become invalid. So it's a very good practice. It should be used periodically. Let's do a quick summary of the things we've learned. So if you have a .NET or Mono application, and for whatever reason, there's no Mac we can mess around with it with numerous ways. We can change every property we want in the view state. We can change the database type, the visibility properties. We can perform cross-site scripting and SQL injection attacks through the control properties, which are rarely validated. And we can do a number of additional things. And in addition to that, if there's no MAC, we can alter the event validation field and execute invisible server-side web controls that we're not supposed to. If the MAC is on, but the event validation is off, we can do the same things. We can execute literally everything we want to in the server side, and we can identify whether or not it exists by analyzing the view state field. And even if most of these protection methods are on, just by finding a callback location in which the developer makes a simple one-line mistake, or locating an older version of the view state event validation fields, we'll be able to execute the server-side controls despite all those protection mechanisms. So after this nice demo, I hope all of you have a lot more tools to assessing the security of dotNet fields, and I hope that the finding in reports, which is MAC is turned off, will become extinct, and you'll be able to present something more interesting, something more sexy, at least as an exploit. And for that purpose, the vehicle project was uploaded online. It's currently available in its GitHub repository, okay? It's an open source project. It's a ZAP extension. There's an installer. All you have to do is next, 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 and it should work properly. That's the GitHub repository for those of you who want to see it live, okay? Plenty of versions for Linux, for Windows, and so on. That's pretty much it. Any questions, guys? Yes? No, but since it's integrated with the ZAP recent feature, just like burp recent feature, ZAP recent feature, you can actually copy and paste it. It should work properly. And if you want to, you can do something else. You can forward the communication from burp after copying the view state to ZAP. So it will treat it as if it is the original view state and mess around with it, okay? So you can do it either way. You just have to work around a bit, okay? You just have to send the communication to another proxy to ZAP. Any other questions? Yes?
When you were enforcing the controls and you had the exception.
Yeah.
The exception occurred because you were using the local host. Is there some sort of similarity or some sort of differential analysis that you do if exceptions are not turned on to make it faster?
If there's no exceptions turned on, we currently support blind enumeration features. So
it'll fall back to the blind?
No, you have to choose either blind or error-based. Okay. But if there's no errors, okay, it won't be active. You won't be able to click it anyway. So you have to press the blind. It's almost as accurate. We've worked really hard on the blind enumeration features. We actually exported the features from a project called Diviner, which we really invested a lot of time in making those blind comparisons. So it should work pretty well in most cases. I'm not claiming it's bug-free, but we're working on it.
Great,
okay?
Thank you.
Other questions? Yes, James, right? I think. So a picture on the website.
Hi there. Another mitigation feature you could use then is randomizing the names of the controls, or putting on a random key at the beginning, and then changing that periodically as well. And it'd stop being able to reuse the same signatures again. Would that work?
Yeah, but you'll be able to do something else to counter that, such as if the control names can be changed dynamically. They can be changed in design time. So accessing the view state or accessing snapshots of the website from previous versions from Webback will enable you to scavenge the names. So it's good. It will work. It'll probably help a bit, but it can be bypassed using other means. Okay? Other questions? So if you have any other questions, I'll be here for the rest of the day. I hope you enjoyed, and enjoy the rest of the conference.